Okay, let us begin. Today we are going to talk about straight lines. And we're going to learn how to graph them before we learn about their equations, because that makes sense in our syllabus. So the next topic is section 2.4 in your textbook, graphing linear equations. So let me first tell you a linear equation in x and y is an equation that can be written ax plus by c, where a, b, c are constants. A and b not both. We often write it in the form. Who knows the famous form for the equation of a line? Yeah.
Don't know the zero way plus the.
No, the general form, the general formula for the equation of a line. Do we know it? Y equals mx plus b. Right. In the next section, I'll tell you what those parts mean, but well, actually tell you here, because I sort of ignore the syllabus sometimes and tell you things ahead of time. Where m is the slope, right, which we're going to talk about that in a bit. That's the rate of change. And b is the, what's b? Y-intercept, right? Which is where it touches the y-axis, right? That's the point where the line touches the y-axis. Right? We're talking about the Cartesian axis here. Right? So there's the x-axis, which is the horizontal one, and the y-axis, which is the vertical one. Right? And we draw graphs on this axis, right? So I'm going to quickly get to the point. Right now, all we care about is graphing them, right? How do we graph them? Someone tell me, what's the easiest way to graph a straight line? Like I told you to graph a straight line. What would you do?
Get points.
What points?
The x and y. 1, 2, negative 1, other 2, 3, 4.
Okay, how many points do we get? 2, exactly. The easiest way to draw a line is to get 2 points on the line. Right? You don't need 3, you don't need 4. 1 is not enough usually, unless you have more information like the slope. If I know the slope and a single point, I can find the equation and graph it ultimately. But let's say from scratch, if I want to graph it, the first thing I do is get 2 points. And then all you have to do once you plot those 2 points, you draw a straight line to them. Get 2 points, plot them. And draw a straight line through them. Right, that's basically all we're doing in this section. Right? So Let's do some examples. Oh, I also mentioned usually the best points to find. What are the best points to find usually?
AB.
What's AB? X and Y intercepts. Notice that this is not always possible, but as long as it is, do it. Cases where it might not be possible are, for example, with a vertical line might not have a y-intercept, or a horizontal line might not have an x-intercept, right? But you'll be able to figure them out when you see them. Vertical lines look like x equals some number, right? And horizontal lines look like y equals some number. So you'll know when you have such a line, and you won't really need 2 points. You just need to know any 1 point, and that will be good enough. But in general, in this general form, where all of these guys are non-zero, the best 2 points to find are the x and y intercepts. And how do we find the x and y intercepts? Let's say I want to find the x-intercept.
Y equals 0.
Right, you plug in y equals 0, you solve for x, that gives you the x-intercept. If you plug in x equals 0, solve for y, that gives you the y-intercept. Okay, seems like you guys sort of know this already, so let's just grind through a few examples here. Graph the following. X plus y equals 1. Leave a lot of space for that. X minus y equals 4. C. X equals 1. Y equals minus 1. Let me do this one first.
Thanks, Mom.
Are we done with over here? So we're going to do all these, and knowing this, they're actually going to go by a lot quickly. I have 1, 2, 3, there's 6 examples there. I have 11 examples in total, but they'll go by quickly once you get into the groove of them. All right. Let's graph this. What does it look like? What do we do?
Move the x to the other side.
No, we do what we said we want to do. We want to find x and y intercept, right? So let's say I want to find the x intercept. This means y equals 0, right? Which means your x is 1. If I want to find the y intercept, it means x equals 0, which means y equals 1, right? And that's all there is to it. On the x-axis, you plot the point where it's 1. On the y-axis, you plot the point where it's 1. You draw a straight line through. That's it. So like I said, linear equations, these are going to be some of the things you graph really quickly. Later in the semester, you'll learn to graph quadratic equations. Those aren't that bad, but they're a little more work than this one. But with straight lines, that's pretty much it. You find any 2 random points. Usually the x and y intercept are the best ones because you get to plug in 0. That makes your computation easy when you plug in 0. So that's why I say those are the best points. It's usually easy to compute things when you just kill them with 0. This one.
Excuse me.
Yes.
Again, I'm sorry to interrupt, but can you please explain a little bit more in details, because I'm not getting the
Which?
graphic linear equation. So
Which part?
How do you plot those zeros? How do you apply the zeros?
I'm
How do
finding
you
the
get
x-intercept.
the graph right there. Huh?
I'm finding the x and y intercept.
Oh, okay.
Okay. Do you understand what these are?
Okay.
Okay. So the x-intercept is where it touches the x-axis. The y-intercept is where it touches the y-axis. Right? Now I just want to find those 2 points.
Right.
Notice that when you're on the x-axis, the y value is 0. Right? Your y-axis is the vertical one, and it counts up numbers. 1, 2, 3, etc. Right. So now, if I'm given this equation, all I need to do is find 2 points.
Right.
I usually want to find the x and y intercepts because they're the easiest ones to find.
Oh, because
So-
y plus x plus y.
X plus y equals 1. So now, if I want to find the x-intercept, I just plug in y equals 0 and solve for the x value. Right? So if y equals 0, I would get x equals 1. Right?
Right.
And then I put that on the x-axis.
Okay.
Then if I want to find the y-intercept, that's when x equals 0. So I plug in x equals 0, and then I get y
You
equals
have a
0.
value in front of the x, right?
Right.
That's why
There's
you
no,
put 0 instead of.
no, I try to put 0 all the time because it makes my life easy.
All the time?
All the time when it's possible. These are 2 cases where it might not be possible, but I have examples to do with those.
Oh, okay.
What about this one? You do the same thing. So let's find the x-intercept. Meaning, we plug in y equals 0. So this means 2x minus 0 equals 4, which means x equals 2. Find the y-intercept. This means x equals 0. So there's a 0 minus y equals 4, which means y equals minus 4. And so I'm going to go on my graph. X is the horizontal, y is the vertical. So my x-intercept is 2, so I'm going to go here and plot 2. My y-intercept is minus 4, that's down here on the negative side, minus 4.
How do you know minus 4?
I had minus y equals 4. Multiply both sides by negative 1.
You multiply both sides.
By negative 1, yes, to change the sign.
The top 2?
No, that wasn't necessary. Right, if I had
I never
2,
learned it this way, that's why it's kind of new. So I learned it differently.
how did you learn it to draw a line?
Yeah, I learned it like that, but I guess the way my professor broke it down, he broke it down more thoroughly. So I feel like the way you break it down is kind of like straight to the point. Me, the kind of person I am, how I learn step by step, kind of. I feel like if you just.
Okay, what steps are you missing between here and here?
Like the zeros. The zeros to each thing. When you take in the x-intercept, right? You just,
Okay, let's worry about this equation. How would you solve it if it were you?
I would minus
You would minus 4 to do what? You want to move the 4 over here? Okay, so you would subtract 4. And then what would you get?
minus 4 equals
Minus 4 equals y? Now you're skipping steps, aren't you? You still have the minus y over there, you have to move it over. Now you're trying to skip steps, trying to confuse me. I didn't learn like that, you know, you have to break it down. That's what we did. Right?
So in reality, you just move the y on the other side.
I moved the y over here and the 4 over there. Yeah. I mean, at this point, solving an equation, moving things to the other side is something that you can do if you sit down and do it. I mean, if I do it here quickly, don't worry about it. You just take your time and do it. All you're doing is solving this equation. Plug in 1 equals 0, solve for the other one. That's all you're doing at any given point. So now that we have those two solutions, I'm going to plot the points. So I would plot 2 on the x and minus 4 on the y, and then just connect them with a straight line. So the graph of that one looks like this. This is the x-axis, this is the y-axis. Any other questions? Yeah.
We don't write anything for this line. I mean, for example, k. The name of this line.
The what of the line?
Yeah. For example, we can call it like a k or something.
Call the line, name the line,
Yeah.
something?
Yeah, the name.
Not necessarily. If you're drawing several graphs on one thing, then you might want to label them, but I'm only graphing this, I don't need to. All right, what about this one, x equals 1? What does that look like? This is the vertical line, x through x equals 1. So we have here the axis x and y. Here's where 1 is, just a vertical line, right? This is the point where x equals 1 all the time. So if you wanted to find another point, you can pick another y value, but it will still give you the x equals 1. All points will be along this line. So this is just a vertical line. So here you didn't even need to find the intercepts. Right? This is the case, this is one of these cases where you don't find the intercepts, you just draw it, right? So if I say x equals 1, it just means you find x equals 1, vertical line through that. X equals k is a vertical line. Right, so in this case, k is 1. So I just draw a vertical line passing through.
Is that another way to write it?
What?
K.
K is just a number, k is a constant.
So if it said y equals to 1, which is pretty much do the same thing, but the other way.
Yeah, if it's y equals a constant, you draw it the horizontal. So what would y equals minus 1 look like? Passing through what? Passing through minus 1, right. And so here I can make the comment y equals k is a horizontal line. Passing through. Right, so horizontal and vertical lines are even easier. We don't even need any computation. Just find the number that they say and draw it through that. If it's x equals something, it's vertical. If it's y equals something, it's horizontal. This example?
You have to switch it because the way it is. It's supposed to be set up AX plus BY. We'll see.
You could do that, that's fine. How would you set it up that way?
I think that's times.
Isn't one the y-intercept?
Yeah? Okay.
What
any number and we replace it instead of it.
One is
We
equal
know
to
one way to find the y. And after we
Doing what?
3x plus 1 equals 0 because you need the x-intercept. So it's
Right.
0.
You do exactly the same thing, right? You don't have to make it any more complicated. Always find it, unless it's a vertical or horizontal line, always find the x and y intercept. X-intercept, plug in y equals 0. Solve for x. How do you solve for x? Minus 1 from both sides. Then divide by 3. Then you find the y-intercept, which means you plug in x equals 0. So y is equal to 3 times 0 plus 1. So y is just 1. And so now you graph this. So here I'm going to plug in y equals 1 and x equals minus a third. Minus a third is somewhere over here. Minus 1/3. Graph a straight line through that. What about this one? You basically do the same thing. Find the x-intercept, find the y-intercept. X-intercept means you plug in y equals 0. How do we solve for x?
I got rid of the fraction.
Okay, we can do that if you like.
I times, well, basically everything by 2.
So you multiplied everything by 2.
Yeah.
So 0 times 2 is 0. Minus a half times 2 is just minus 1. Minus 2 times 2 is minus 4. Okay, and then what?
Add 4 to both sides.
Well, now you have a minus x here, right?
Yeah, no. Well, what I did was I add 4 to both sides and it becomes 4 equals negative 1x and then I divide negative 1 from both sides.
Okay. Or you could have just moved the x.
I'm used to it that way.
You could have added the x. So x equals minus 4. So now the y-intercept, how do we find the y-intercept?
Substitute so x.
Plug in x equals 0. So there's 0 here, minus 2. 0 minus 2 is just minus 2. And so now we graph that. Y is minus 2. X is minus 4. Connect those with a straight line. Letters at F. Let's see who I confused by doing this. do we graph this line? Hmm?
0 equal to minus x. X.
Find the x-intercept.
And x equal to
And find the y-intercept.
y equal to
Graph that. X equals 2, y equals 2. Now I'm doing this many examples so you can see a pattern, right? So there's a graph of a straight line. If it's x equals something, it's just a vertical line. If it's y equals something, it's just a horizontal line. In every other case, what do you do to graph line? Find the x-intercept, find the y-intercept, put them on. Find the x-intercept, find the y-intercept, put the points on. Find the x-intercept, find the y-intercept, put the points on. Find the x-intercept, put the find the y-intercept, put the points on. Right? Find the x-intercept, find the y-intercept, put the points on. Right? At some point, it just becomes like that. Right? So, which is how it should be, because a lot of times the problem is you run out of time, right? So we don't want that happening to you. So the goal is you sort of practice something, and this is, again, going back to what I was talking about the first day, it's all form and algorithm, right? Once you know the algorithm for graphing a straight line, it's like that, right? It shouldn't be something that you see that on a test and you're like, oh, you waste 5 minutes thinking about it. That's not where we want to be. We want to just know, oh, straight line, x-intercept, y-intercept, right away, right? So I see. Well, how do you graph this line? Find the x and y-intercept. That should be the answer right away, right? That's what I'm trying to get at here. How do you graph this line? Find the x-intercept and y-intercept. X-intercept, how do we find it?
0 equals.
Y equals 0. Now we solve for x, right? Which is the toughest part of this whole process, actually solving the equations. How would we do it?
Minus 1?
You could subtract 1. There are several ways to do it. You could minus 1. And then what? Divide by minus 3, right? Because you want x by itself. So you divide both sides by minus 3. So this gives you 1/3 equals x, right? Because negative over negative is positive. Y-intercept, plug in x equals 0. So y equals 1 minus 0, which is just 1. So now you graph that. Y equals 1, x equals 1/3. X equals 0, what does that look like?
the same
It's just
as x.
Is it a horizontal or a vertical line?
It's a very
It's a vertical line because it's x equals something. Now, where does it pass through?
0.
X equals 0, right? So it's actually a line right on the y-axis. Right? See that? It's actually right on the axis. In fact, that's something you should have interchangeable in your minds by now. X equals 0 is the y-axis. Right? That's going to be an important concept for you to make the jump. Sometimes you'll have problems in the future where they mention the y-axis and you'll need an equation to make things work. This is the equation, right? Always. For the y-axis, x equals 0 is the equation. Right? What about y equals 0? Hmm?
It's horizontal on the x line.
It's horizontal on the x line.
So it's got the same for the x axis.
That is interchangeable for the x-axis. Right? So it's right on the axis. Right? This is y equals 0 is the x-axis. f of x equals minus 7. How would I draw that?
The x part is 0, please.
Is it 0 equals?
The question comes down to what is f of x?
0.
You think of it as the y, right? This is function notation. I think you saw it in the last class. You sometimes think of y as a function of x. And so saying f of x equals minus 7 is the same as saying y equals minus 7. Right? It's just something you have to be aware of.
Is it always y?
If you have two variables and the other one is in the brackets, then this must be it. Right? So I can say g of x equals 3. You still think of this as y, right? But if I say g of y equals 4, this I would think of as x. Right? You think of whichever one's in the brackets, the function is the other guy. Right? So it's just a way to think about it. Because like he says, sometimes you want to name your functions. You want to call that graph something. So in this case, I just call the graph f. And this is how you would name a graph, right? You say f of whatever variable is the input, and then the other one would be the output. Just so you're aware of that. In pre-calculus and calculus, the concept of a function is super important. So you should know.
How would you graph that?
Oh, well, you graph y equals minus 7, so. Minus 7, horizontal.
So that f and parentheses x means 0?
It means y.
Or it means y on? That's it?
No.
F of x is y.
When yesterday we were going over it, what did it mean? We were doing something similar, that it's minus 0 or something. Right.
Oh, when I said I find the roots of the function.
Yeah.
Right, finding where the function is 0, that's a different thing, yes.
That's a different thing.
But it was still, you still could have thought of the function as y.
Oh, okay. But it looks, that specific f and the x looks pretty much the same. It's that
Yeah.
piece.
It's just when I ask for roots or the zeros of a function, I'm specifically asking where is the function 0.
Okay.
Right. But in general, this function is just a rule that tells you what to do with your inputs and outputs. I believe in the syllabus you get into functions later. But yeah, we talk about functions in detail later, I think. So. So hopefully you get the idea. You want to graph a line. If it's not horizontal or vertical, find the x-intercept, find the y-intercept, plot them, draw a line through. Now we're moving on to section 4.1. Where we're going to talk about the equations of the line. We're going to talk about the slopes of the line. We're going to talk about when we know lines are parallel and when we know lines are perpendicular. We only have an hour today. I'm not sure if we're going to get through all of those. They're simple concepts, but I want to write down all the definitions and everything so it's clear. So that might take a while. Let's just jump into it. Let's start with the slope, first of all. We're going to talk about the concept of the slope. Let's see how much you guys know to begin with. Can you describe the slope of these lines using signs?
Using
Signs. No. Positive, negative, etc.
that one is positive.
This is positive slope, right? This is a description of how the line looks. You say this is positive slope. That means you go up, moving from left to right. Right? So if you're moving from left to right and your line is going up, you say that's positive slope. What about this? A horizontal line. Slope is 0. Then you say the number is 0. This just means horizontal. This one is called, described as negative slope. This means you're going down, moving from left to right. No slope. I feel like you guys know about this already. You've been studying. No. This means no slope. Right? There are cases where, probably not in this class, but in future classes, you might think of it as the slope is infinite. So it's not really a number. Right? You can describe the slope as infinity. And why we would describe it like that is based on the definition. The slope of a line between two points. Let's call them x1, y1, and x2, y2. Is given by, M is the letter usually to denote it. M stands for slope. y2 minus y1 over x2 minus x1. This is the same idea of rise over run. Right? Tell me how high you're going as you're moving horizontal, and I can figure out the slope. It's just a rate of change is how you want to think about it. In calculus especially, that's how you're going to start thinking about the slope of a line as a rate of change, how fast something's moving up or down as you move horizontal. Right? So it's the idea of rise over run. Right? So you take the difference in the vertical value over the difference in the horizontal values, and that gives you the slope. Let's do some examples. Before I start writing a bit further, I'll have more space. How do we find the slope?
You take y is the second y.
So it's m equals.
Minus 5.
Yeah, so probably the first thing you want to do is label them so you keep them in order, right? Because it matters who you're subtracting, the order that you're subtracting. So the first thing I do is I probably, just scribble with your pencil over the points and say I'm calling that x1, y1, calling this x2, y2. It actually doesn't matter who you name which, but it's very important that you keep them consistent, right? I could have called this x1, y1 and that x2, y2. It doesn't matter, I'd get the same answer. But you have to know which pair goes with which, right? Because you have to take the y2 minus the y1 and take the x2 minus the x1. You don't want to mix these up. So at first, call them something. Call this my x1, y1, and this my x2, y2. So start there. Now, we can apply the formula. Right?
-5 minus
Right. So y2 minus y1 over x2 minus x1. So y2 is -5 minus y1 is 3 over
Minus 4.
x2, which is -4, minus
Minus 2.
x1 is 2. So this gives us what?
Over 3.
8 over 6.
-8 over -6. The negatives will of course cancel, and I can divide 2 into each, right?
Yep.
So it's 4 over 3 is the slope for this line. The line going through those points. What about this one? Again, you label them x1, y1, x2, y2. So here, slope 1 minus -4, 2, which is x2, minus 3. So this gives us 1 minus a -4 means +4. That's just 5 over -1, right? Which divided by -1 is the same as multiplying by -1. So in this case, the slope is -5.
So can you remind me how did the 5 become positive on top again?
It didn't become positive, it's -5.
I mean, at the top you said 1 minus 4 minus 5.
Oh, because minus a minus is plus. Negative times a negative is positive, so I have +4 plus 1 is 5. Okay. What about this one? Yeah?
No slope.
How do you know there's no slope?
Because it's divided by 0.
Right, which we never divide by 0. Remember, that's one of the things we never do. If you say x1, y1, call this x2, y2, then you try to plug it in for the slope. You said m equals -3 minus 1 over, this would be 2 minus 2. You said that guy is bad. Right, so it can't work. So this one is a trick question, it has no slope.
That would be the correct answer.
Yeah, the correct answer would be no slope. What kind of line is this? Has to be a vertical one if it has no slope. In other words, this line passes through x equals, what would be the equation of this line?
X equals 0. Well,
X equals 2, right? Your x value is 2.
Oh, yeah.
It has to pass through 2. So this is actually a vertical line. Notice that it passes through the point 2, comma 1, and it passes through the point 2, comma minus 3. It's a line that the x values are the same. It has to be vertical. Right? Where 2 random points have the same x values, it has to be a vertical line.
why you said it's 0 on the slope?
I never said the slope was 0. I said there's no slope. It's not the same as saying it's 0 slope. 0 slope is a very different thing from saying no slope. By saying no slope, I'm saying it cannot be described by a number. That's what I mean. Like, I mean no in the sense of like really no, not 0.
So in that case, you just put x equal to and then graph it.
No, this is the answer. No slope. There is no slope. It doesn't have a slope.
Plus 2 minus 2 equals to 0.
I just graphed this to illustrate what's going on. Why it has no slope is because it's a vertical line. How do you find the slope here? Yeah? It's just the 3. Right? Which, when I tell you about the
X plus b.
the y equals mx plus b, it's the slope. Right? So I know it's just the 3. But, yeah. I mean, I could do a long way as well. What we could have done is just find 2 random points and then use this formula, but as I'm about to show you, doing that would be unnecessary because we actually have a nice formula for that. But we are not going to get to that right now. Let's talk about parallel and perpendicular.
So the y-intercept would be 1.
The y-intercept would be 1 and the slope would be 3.
3 over.
Definition. 2 lines are parallel if. How do you know 2 lines are parallel?
Yeah, same
They
slope,
go in the same direction.
They
have the same slope.
Yeah, they go in the same direction if they have the same slope. Right? Parallel just means they can go in the same direction, but they never get to touch, or they're actually one in the same line. They're right on top of each other. So in that case, it means that the rise over run is exactly the same. So you get that sort of relationship between the lines. So if L1 and L2 are lines with slopes M1 and M2 respectively, then L1 and L2 are parallel if M1 is literally equal to M2. What about perpendicular lines? What's the relationship?
They're the opposite.
It's not just the opposite.
Negative reciprocal.
Negative reciprocals. Meaning one slope has to be 1 over the negative reciprocal of the other one. We can prove this. The proof is not that bad, but I won't. Definition. 2 lines are perpendicular. What does the word perpendicular mean?
90 degrees.
It means they meet at 90 degrees. If one way to write that is the product of their slopes is -1. So it means your lines look like this, where there's a 90-degree angle between them. So well, using the same notation, L1 and L2 are perpendicular if M1 times M2 is -1, or you can say 1 is just the negative reciprocal of the other. Right? Most people remember it this way. That's fine. Let's put this in the box. Examples. I mean, I doubt you'll get asked questions like that, but they're important for you to know when we're solving problems in general. Fill in the blank. So, if the slope of one is 2/5 and the slope of the other is -5/2, then they are perpendicular, right? If you take one, you flip it and put a negative sign, you get the other one, and so it's perpendicular. What if the slopes were 3 and -3? No?
It's still perpendicular?
Parallel, they are parallel.
No?
Why do you flip the top over?
What?
Why do you flip the negative?
This one?
Yeah.
No, I'm just saying, pretend you have this situation. Let's say you're in a situation where you know the slope of one line is 2/5 and the slope of the other is -5/2. What could you conclude about these lines, their relationship? You could conclude they're perpendicular, right? Because this relationship holds. Right? You have to remember that 1/2/5 is keep change flip, right? Take 1 over a fraction, it's just flipping the fraction, right? So here, at 2/5, I flipped it to get 5/2, and there's a minus sign here. Whenever you see that happening, it means they're perpendicular. So if the slope of one is 3 and the other one is -3, parallel or perpendicular?
Parallel. Parallel.
Trick question, neither. See if you guys are paying attention. Right? They're not the same. One is 3, one is -3, so it's not the same number, so they're definitely not parallel. And if I take the negative reciprocal of 3, I get -1/3, which is not -3, so it's neither. That was a trick question. What about this one? There's parallel because slopes are the same. Right? So be careful. Just because one's positive and one's negative and they might look the same, that's not enough, right? You have to flip it as well. And that's how you get it. So later we'll be doing examples where I might give you the equation of a line and I ask you to find the equation of a line that's perpendicular to it, that passes through a certain point, and you need to know, oh, I need to change the slope in this way in order to do that. That's going to be important to know. Let's talk about one of the forms of the equation of a line. The famous one that you guys told me at the beginning. I don't think we're going to get to any examples. Suppose a line has slope m, passes through the point 0, b. That is, B is the y-intercept. And let xy be any random point on the line. Then by the slope formula, what would we be able to say using the slope formula? If I want to write an equation with m in it and these 2 points. The slope formula says y2 minus y1 over x2 minus x1. So if I have 2 points on a line, and I want to find the slope, I can just name them. I can call this x1, y1. I can call this x2, y2. And so the equation for my slope would be what? M would be equal to y2 minus y1 over x2 minus x1, so that's just 0. So this means I just have m is equal to y minus b all over x. So what I can do is I can multiply both sides by x. So m times x must be y minus b. Then I can add b to both sides. And x plus b equals y. In other words, y equals mx plus b. Right? That equation came from the slope formula. So we have y equals mx plus b. This is called the slope-intercept form. The equation of a line. There are several forms. There are about 3 you need to know. The other one can be derived in the same way. Let's write it down before we read. The equation of the line through the points x1, y1 through the point. So let's say I only have one point in this case, x1, y1, that has slope n is y minus y1 equals n x minus x1. All right, so if you're given a single point and the slope, you can still get to the equation of the line by that. And you can find that equation in the same way I did here, right? I just called this x1 and y1, and then the generic point xy is called x2, y2, and I plug it in the slope formula and I can rearrange it to find that. And so this is called the point slope formula. Because you need a point and the slope. Here you need the slope and the y-intercept, so it's called the slope-intercept point. Next time, I guess we'll pick up with this. And yeah, about what I mentioned in class last time, yeah, it's actually happening, so it's official. This is my last class with you guys. I don't know who's going to take over, but I'll tell him where we got up to when I meet him. So, or you guys can tell him. We got up to we just wrote down the equation line. We didn't get to do any examples. But yeah, so I guess we stop there. Final words, because I know not everyone tells you these things, but don't do those things I told you guys not to do, right? Even though people don't emphasize it. Some things to do, read through your notes like the same night, right, or the very next morning. If you read through it right away, it will help you retain things longer. Again, practice, 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 and practice with, not just practice for practice sake or doing the homework to get through it. Really focus on form and algorithm, and especially if we write down a rule, and I have a form in that rule, your goal should be to try to get things into that form in order to do it. So, for example, yesterday, I just wanted to mention this. Yesterday we were solving an inequality where it was quadratic. I sort of forget which one it was exactly. But it said something like x squared plus x less than 6, or something like that, right? And someone said, oh, move the x to this side, right? To write this x squared less 6 minus x. But in general, this is something you would not want to do, right? And why is it you wouldn't want to do that? Because pretty much every formula that they tell you with a quadratic equation, they write it in ax plus by plus c, right? Means anytime you want to solve anything that's a quadratic, get it in that form. Bring everything to one side, right? That's how all your formulas work, right? So that's the sort of thing I think you should focus on, right? Always know the form that something comes in, right? And always know the algorithm. Like, for example, for a straight line, graph it, what's the algorithm? Find x and y intercept, plot the points, right? These are just things you should know, and it will make your life a whole lot easier. And I guess that's it. You can have fun. Your